Alright, welcome back to Math 1720. We are in Chapter 7, starting Section 2, and we're going to talk about the law of sines a little bit more, but we're going to talk about the cases where we can't solve using the law of sines, and where we can solve and it might have more than one possible solution for it as well. So we're going to go through those three cases. If we have a side-side angle approach, that gives that to us. So when you're going to apply these on your homework assignment, if on your homework you're given a side, and then an angle, that's where these three scenarios are going to take place. Okay? So if you're given the lengths of two sides and then the angle opposite them, all right, this doesn't 100% like show it with this this drawing here. This shows more of a side angle side. Okay? But we're going to be looking at the case where side-side angle occurs. It can produce 0, 1, or 2 triangles. And that's this piece right here. So make sure that you write this down in your notes with the sketches and the number of triangles that it produces. Okay, so what you have to think about is applying our domain and range to our sine function here. So if we get, if sine of b is greater than 1, right? Sine has to go between -1 and 1. We're going to get no triangles, okay, because it doesn't exist. Okay, if sine of b is equal to 1, we know that's a 90-degree triangle, right? Because sine of 90 is equal to 1. So that's going to give us a right triangle. We can also have the value of the angle, all right, the sine of b, the ratio. So when I say sine of b, I'm saying the ratio. As long as that ratio falls between 0 and 1, I'm looking at the third one down, all right, we can have a triangle. Okay, it'll be greater than 90. We'll have an obtuse angle. Okay, we also have another scenario where the angle or the ratio is between 0 and 1, but it produces two possible triangles. And you look at the criteria on the side lengths there. All right, so the height, okay, or the perpendicular height of the triangle, if it's less than A and less than B, all right, we're going to get that scenario where we have two possible triangles. We're going to do an example involving all the cases here, probably except for the 90-degree, because we've done so many triangles using 90 degrees, and we can just use SOHCAHTOA to do those. But if you note the criteria on A and B, little a, little b, it'll really help you understand as you go through and we do these examples together, how many triangles it's going to have. So if we take a look, all right, if we just try sketching this, okay, if A is obtuse, okay, we have the possibility of getting 0 or 1 triangle. It just depends on what B is, okay. If sine of angle B is greater than 1, all right, or if little b is greater than or equal to A, you're not going to get a triangle because A has to be the largest side across from the angle, okay? We can't have the hypotenuse. So this all stems around understanding where A, B, and C are located, all right, and whether we're generating it around the largest angle, okay? So if A is an obtuse angle, there's no way that B can be an obtuse angle as well, or a larger angle at the same time, and we physically get a triangle. Okay, does that make sense? We can have those two scenarios, and we'll get into that when we get into the vectors, but that's really kind of what's going on here. Alright, so if we want to apply the law of sines, okay, this is to our side-side angle stuff. For any angle theta of a triangle, okay, the ratio is between 0 and 1. It cannot be 0, but it can be 1. Okay, so if sine of theta equals 1, then theta is 90. We know that, right? The ratio in that case is the 1. Okay. All right, so if we have sine of theta equals sine of 180 minus theta, it's supplementary. We should know that, right? They're going to have the same sign because sine is positive in the first quadrant and in the second quadrant. Okay, this is the most important piece here when we're applying the law of sines at step 3. The smallest angle is always opposite the smallest side. The largest angle is always opposite the largest side. That holds true for all triangles. Okay, that's just a rule in general how we deal with those. So you need to make sure that you pay attention to that as we're doing these problems. All right, so this is example 1. We're going to have the case of no such triangle. So we got to think about some things here. Can we look at it and analyze it real quickly? Maybe, maybe not. We can maybe solve this one because if I look at this right now, all right, A is 25.1, B is 8.94. So right now we're good because A is bigger than B, all right, but we don't know until we actually solve this if it works out right. So we're going to work through this problem here using the law of sines. Okay, since we're solving for the missing ratio piece, we're going to keep those ones on top. Okay, so we're going to use the alternate form. So we're going to use sine of A over little a equals sine of B over little b. Remember, you can write it either way. You can write it as A over sine A equals B over sine B, or we can write it as sine of A over A, sine of B over little b. The advantage to doing it this way is we're looking for an angle. Okay, if we were looking for a side, we would have the side lengths on top. If we're looking for an angle, we keep the angles on top. Okay, so when we substitute in our given values, this should be pretty easy for us. All right, we substitute in our given values and we solve for sine of A algebraically. So we're going to multiply both sides by 25.1. So you're going to get 25.1 sine of 55 degrees 40 minutes divided by 8.94. When we do that, we get 2.3184. That should send up some red flags for us there. What happens there? We can't have anything greater than 1. Okay? So since A is greater than 1, this is impossible and no such triangle will exist. Okay? Even if you try and draw this triangle, all right, it's going to look like this in general. We could have kind of sketched it ahead of time, but that's really what it's going to if you were to sketch the figure. No such triangle could possibly exist there with that length being 8.94. Okay? So if we are the ambiguous case, that's what really we're talking about here. That's when we're given two sides and the angle opposite one of the sides. All right, so with that, we're still talking about side-side angle here. All right, so let's look at this case here where we have two possible solutions. Okay, two possible solutions potentially. All right, so we have this triangle here, ABC, and A is 55.3, little a is 22.8, and B is 24.9. Okay, so let's see what happens here. Once again, we're solving for angle B. We need to see if angle B is technically, the correct length or correct measurement. Sorry, I can't speak there. All right, so we're going to substitute in our given values, and we find that sine of B is going to be equal to 24.9 sine of 55.3 divided by 22.8. That gives us 0.897, right? That's in the realm of an acceptable answer, right? It's between 0 and 1 for what the sine of B is going to be. There are two possible scenarios there, all right, for theta to be that angle. So this is where, how do we get that angle? Remember, you're going to have to do sine inverse. So second sine on your calculator of 0.897868. And yes, type in as many of those as you possibly can to get the best accuracy that you can on your angle measurements. All right, so there are two possible scenarios here between 0 and 180 degrees where this occurs. All right, so when you do that and you substitute in, right, you hit second sine inverse of 0.89786, you should get roughly 63.9 degrees. Okay, that's the first quadrant angle. The second quadrant angle, you're going to take 180 degrees minus 63.9. Okay? So that should be the two angles that suffice for this triangle. Now, some of you guys might have asked in the beginning, how do we know that we can work through this triangle? Because right now B is greater than A, and you think that that shouldn't exist. Well, you got to be careful on this one, because when we draw this out, all right, it'll make more sense that we can drop that perpendicular height. And remember, the height has to be less than A and less than B. And in this scenario, that really works out. So you can't just necessarily look at these all the time and be like, yeah, it's not going to work, or yep, I got two, or oh, it's just the one. You really generally need to work through them, and then once you work through them, you can conclude some things. Okay, so based on working through the math, then you'll understand, what's up with the problem. So we have a couple different possibilities here, because we have to check and make sure the triangle is valid, right? I'm going to step back a slide here. We have one angle is 63.9. That's going to be for one triangle. So we're going to use the 55 degrees and the 63.9 degrees and try and make a triangle. And we're going to use the 55.3 degrees and the 116.1 degrees and try and make another triangle to see if they're both valid. Okay, so that's really what's going on here. So here, we're going to take 55 plus 116.1. That tells us we have 171.4. That's less than 180 degrees. So B being 116.1 is a valid possible solution for that, okay? So we can solve the separate triangles out separately. We checked the 116 to make sure that it worked, right? Remember, all the degrees in a triangle need to add up to 180 degrees. So if we solve these three triangles separately, all right, so for the C is going to be for triangle 1, okay, and then the C2 will be for triangle 2 when we go through this. Okay, so 180 minus A minus the B that we calculated, all right, gives us a 60.8 degree triangle. Okay, or not triangle, but one is 60.8, the other is 63.9, and the other is 55.3. So those are the degrees on our triangle here. Okay, then using that we can find side length C. So once again, since we're finding the side lengths, change the way that the law of sines looks, okay? And then substitute in what we have found, all right? We know what A is, we know what big A is, all right? And we know what big C is now that we calculated. So now we have to solve this for the side length C1. And remember, we're just working with the first triangle because this problem has two possible triangles at work. So this is just for the first triangle. All right, and then we're going to work through the second triangle. So in this case, we're going to multiply both sides by sine of 68 degrees. Make sure you're keeping the argument in parentheses when you do this for order of operation purposes. So when you plug this in your calculator, put the numerator in parentheses, and then you're going to take 22.8 times sine of 60.8. All right, I would even just hit enter after that and then go divided by sine of 55.3. And make sure that you work through this and get 24.2 for your solution. So we've fully solved the first triangle. We have found little c and big C. Little c is 24.2 and big C is 60.8, and the triangle is a valid triangle. And then above we calculated, yep, that the other triangle is going to be valid. So we're going to solve the second triangle for this problem here. All right, so we're going to still use the 55.3. Okay, that one was given to us. Now we have to use the 116.1 that we got, because that was the alternate solution, right? And we have little a and little b. Don't use the other c. Remember, little a and little b were given to us initially from the beginning here. All right, so we got to find our third angle. So it's 180 minus angle A minus, all right, sorry, let me start that one over. We got to find the last angle, so it's 180 minus 55 minus 116, all right, that we all calculated, and that ended up being 8.6, okay? So our big C for this triangle is going to be 8.6. Now we're going to use that to find little c for this triangle. Same way we did for the last triangle, set up A over sine A equals C2 over sine of C2. Now that we know big C2, right, we can substitute everything in. So same calculation in your calculator, put the numerator in parentheses and then the sine argument in parentheses, or do the numerator, do 22.8 sine of 8.6 divided by, hit enter, then hit divided by sine of 55.3. All right, so when you get the length is going to be 4.15 feet. All right, and then I'm going to show you both of these drawn out, so it'll make a little bit more sense with the calculation. So in this example, the ambiguous case of sine, we were able to get two distinct separate triangles out of this. All right, and they both look like this. All right, so the one on the left, that's the first one we did. All right, and that's based on the first quadrant angle of the 63.9. The one on the right is based on the second quadrant solution, right, that was 116.1 degrees. So those are the two triangles that we can possibly calculate when doing this problem. Alright, so the number of triangles satisfying the ambiguous case. So once again, go back to that chart at the beginning. Alright, so we're going to say that A and B and angle A are given. Okay, so we can use the law of sines to calculate sine of B. Now these are just the rules again. So when we apply the law of sines, so this is like the first example I did. When we apply the law of sines and it results in an equation having sine of B greater than 1, okay, that's outside the range of sine, no triangle can possibly satisfy this condition. Okay, so the range, it's outside the range. Remember, the range has to be between -1 and 1 for sine. Okay, it's greater than 1, it's outside the range of a sine value. And we reiterated this when we did the chart too. If the ratio, if sine of B ended up equaling 1, we get one triangle, and that triangle is a right triangle because sine of 90 equals 1. Okay, then the third case here, all right, where we have either one or two conditions. You have to test. It's not 100% guarantee saying that when you have the case like we did in example 2 that you are going to have two triangles. You might only have one. That's why we had to test, right, and see if the 116 degrees was valid, if we still had room left to get to 180. If we would have added those up and that total would have been greater than 180, that case would not have been true and we would have only had one solution there. So you really have to check the triangle for those cases. Okay. All right, so if sine of B is between 0 and 1, it's the 1 or 2 case scenario. And we have to break it down, okay, like we did in example 2. So if the sine equaled some constant k, and we found the angle, all right, and we're good, that's our first quadrant, we're going to have one triangle for sure. It's the second one that we had to validate that I was just talking about. We have to make sure that we can take 180 minus the first angle we found, all right, and we get a large angle. Okay, we'll get a larger, probably more obtuse angle. And then we have to see if there's any leftover space to make sure that all three angles would add up to 180. So like in the first example, we had like 53 and 116, right? And that came out to 170 something. So that was valid because it wasn't at 180 or greater, so we were able to get that really small angle for it to work. So this all applies to the second example that we did. Alright, so let's do another example here. We want to solve triangle ABC. We're given, alright, angle A is 43.5, little a or side length A is 10.7, and side length C is 72. Alright, so first approach, write out your law of sines, and I would choose the one where the angle's on top because we have the two side lengths. We're not looking for a side length, we're looking for angle C. Alright, we got to make sure it's valid. Alright, so we're going to substitute in the given values that we have. Alright, we're going to multiply both sides by 7.2 and make sure that you get this in your calculator. Now remember that 0.46319,186 number is not the angle. That's just saying that sine of C is 0.4631. What you have to understand is that between 0 and 1? Yes. So we know we're going to get at least one valid triangle out of this because the sine of C is between 0 and 1. So we know that that's good. Now you have to actually find the angle C. So remember that that's going to be, you have to hit second sine on your calculator. That's sine inverse to get the actual angle. So you're going to do sine inverse of 0.46319,186. When you do that, you approximately get 27.6 degrees. Okay, so now we have to check and see if this makes two triangles. Okay, we know one works for sure. So you're going to have 180 minus 43.5 minus 27.6. All right, that'll give you the missing B that we need, okay? But now we have to see if the second quadrant angle works, okay? So we have to check and see what that is. So when we check the second quadrant angle, we're going to use that 27.6 as a reference angle, Alright, so we're going to do 180 minus 27.6. That gives us 152.4. Okay, 152.4. Well, we have to validate it. Can we make a triangle with 43.5, because that's what A has to be, and 152.4? If we add 152.4, which would be the alternate angle C, and 43.5, we are already well above 180 degrees. So we know that the second quadrant triangle, okay, will not exist. It's not going to be possible. Okay? So the 152.4 is not a possible triangle for us because we're already over 180 degrees only with those two angles. We can't even have a third one. So we know that the only triangle that exists is the first one with a 43.5 and a 27.6 degree triangle. So now we can solve everything. So it's 180 minus 27.6 minus 43.5. That gives us 108.9. So we're just solving the first triangle here. And if we know that that's 108.9 now, we're able to find little b, now that we have big B. Alright, so use the law of sines with the side lengths on top. So you're going to have b over sine b equals a over sine a. Okay, in this scenario. And when we do this, okay, multiply both sides by sine of 108.9. Once again, do 10.7 times sine of 108.9 in your calculator, hit enter, and then divide it by 43.5. You should be getting 14.7 for side length B. So, not too hard. We had to validate, whether the second triangle was going to exist or not. It did not in this case, but it did in example 2. Okay, so example 2 and example 3 are relatively, the same procedure, the same double checking. And so in example 2, we were able to actually get 2 triangles out of that scenario. In example 3, we were only able to get 1 triangle. So whenever you have the case, you don't have to do this test for every single time you apply a law of sines. It is only when you have the SSA, a side-side angle that's given to you, that this scenario will happen. Alright, so let's look at one more example here. So without using the law of sines, explain why A equals 104, little a equals 26.8, and B equals 31.3 cannot be valid for triangle ABC. Alright, so without using the law of sines. So what we need to understand is A is an obtuse angle. And if we remember the rules from a few slides ago, rule number 3, which is important, the largest angle has to be across from the largest side. Well, if A is obtuse, it's 104 degrees. It's the largest angle. There are not any other angles in this triangle that can be greater than 104 degrees and still have a valid triangle. So, what we need to know is, if the side opposite 104 degrees is not the largest side, this triangle can't be valid. So if we note, okay, A is smaller than B here. Little a is 26.8, which is smaller than B, which is 31.3, which tells us this cannot be a valid triangle because A needs to be the largest side length here, and it's not. So we're given that B is greater than A, no such triangle exists. So this one stems from a few slides ago where we did the rules. That comes from this side here where it's applying the law of sines, and rule number 3. The smallest angle is opposite the shortest side, the largest angle is opposite the longest side. So I skipped back a few slides here just so that I could slip this in, you guys could take a look at it. So that's it for chapter 7, section 2. If you have any questions, go ahead and shoot me an email. I feel this one's a fairly straightforward one for you guys, applying the law of sines and working through it and seeing if a triangle exists or doesn't exist. Remember, that's specific to this section, but you have to remember it's the case when you get side-side angle. Alright guys, I will talk to you soon. Take care.